What we want to do is see how the graphs of sine and cosine interact together to make the graph of tangent. We know that tangent of x is equal to sine x over cosine x. So what we're going to do is, as we travel along through the horizontal axis, going through these values of angles, x from 0 to pi over 2 through to pi, through to 3 pi over 2 through to 2 pi, we're going to look at the values of sine and cosine and figure out what they're doing in this fraction, and their combined values, numerator and denominator, how they then turn it into a tangent graph. And this is an important analysis to be able to understand what's going on, because we're going to use this sort of idea of how to analyze two graphs together, how they interact together later on in this chapter. And also in your other classes, your future math classes like calculus, you might need to try to do the same sort of analysis. So let's take this a little bit at a time. The first thing that we recognize is that this is a fraction, and the fraction is equal to 0 when the numerator is equal to 0. And the numerator is sine x. Sine x is this curve here. And so what we see is that sine x is equal to 0 at 0 and pi and 2 pi. If sine is equal to 0, then tangent is equal to 0. So tangent is equal to 0 at 0, pi, and 2 pi. We also look at this fraction and we say it's undefined if the denominator is equal to 0. That means when cosine is equal to 0. This is our cosine curve. So cosine is equal to 0 at pi over 2 and 3 pi over 2, which tells us that tangent has a vertical asymptote at pi over 2 and 3 pi over 2. So we can draw that in. The next thing we need to recognize, as we travel through the first quadrant from 0 to pi over 2, here's the point where cosine and sine are equal to each other. This is why the graphs intersect. When two graphs intersect, it means their outputs are identical in value. And that's at pi over 4, halfway between 0 and pi over 2. When the two values are equal, and they're both equal to 1 over the square root of 2, then their fraction, 1 over square root of 2 over 1 over square root of 2, that's just equal to 1. So it's telling us that at pi over 4, the tangent is equal to 1. Now if we travel to the halfway point between pi over 2 and pi in the second quadrant, what we get is that sine is 1 over the square root of 2, and cosine is negative 1 over the square root of 2. When we put them into the fraction, the result is negative 1. So when we're here at halfway between pi over 2 and pi, the output for tangent is negative 1. So we have that point here. The same thing when we travel from pi to 3 pi over 2. We see that sine and cosine are equal to each other at that halfway point between it. So tangent's output is 1. So halfway between, tangent is equal to 1. And then as we travel through the fourth quadrant from 3 pi over 2 to 2 pi, at the halfway point, cosine is positive 1 over square root of 2. Sine is negative 1 over square root of 2. So the ratio is negative 1. The output down here is negative 1. So we have some key points to work with, and all we really need to know is how to connect them. As we travel from 0 to pi over 4, and we pass through 1, then as we travel from pi over 4 to pi over 2, we see what's happening is that all our values of both sine and cosine are positive. And cosine is heading towards 0, so their ratio is heading towards positive infinity. So the graph curves up like that. Once we pass over that vertical asymptote, we see that from pi over 2 heading towards pi, the whole time cosine is negative, but sine is positive. So we're coming up from negative infinity and we're heading towards 0. So we're coming up from negative infinity. We pass through where sine is positive and cosine is negative, but they're otherwise equal. So we pass through -1. We come up to pi where sine is 0. And then as we work from pi through the third quadrant, from pi to 3 pi over 2, they're both negative, which means their ratio is positive. And we're heading up again towards positive infinity in that vertical asymptote. Then heading from, in the fourth quadrant, 3 pi over 2 to 2 pi, again we have one of the functions is positive, the other one's negative. We're coming up from negative infinity and we're heading towards 0. So look what we created here. We analyzed the values of the two functions. We saw where they made tangent 0, where they made tangent undefined, a vertical asymptote. We looked at some key points where both functions were equal to each other, which gave us an output of 1 here and there, where they were equal to each other except for let's say their absolute values are equal to each other, but they're opposite in sign. So that gave us -1 there and there. And we saw that as we're leaving 0 and heading up to 1, we're heading up to positive infinity. As we're coming up from negative infinity through -1 to 0 to 1 to positive infinity, and then repeat from negative infinity back up to 0 again. Notice that I have half of a copy of tangent here, all of a copy of tangent there, and half of a copy of tangent there. So really, we have 2 copies as we range from 0 to 2 pi. And what we can really view is just thinking about this part from 0 to pi. We have tangent going from 0 to positive infinity. Then we have a vertical asymptote, and we're going from negative infinity back up to 0. This is one whole copy of tangent going from 0 to pi. So we have one whole copy from 0 to pi, and then we have another whole copy as we range from pi to 2 pi. And that's important to compare with sine and cosine, because sine, you have one full copy from 0 to 2 pi. Cosine, we have one full copy from 0 to 2 pi. Tangent is different. It does one full copy in a distance of pi instead of 2 pi. We see that tangent has zeros at 0 and pi. We see it has an asymptote at pi over 2. We see that it's always increasing. And then as we cross over for 2 copies, we see the next vertical asymptote, we see the next 0.